Hello and welcome. So we have seen what is insertion in a tree and how to do a deletion from a BST tree, correct? We have seen that. Now what we will see how to find the minimum and the maximum node in the BST tree. Okay, so first of all, let me throw a question at you. How can you find the minimum and the maximum element? So what is the minimum and maximum element in the tree that you can see on your screen? So what is the minimum element? Minimum element is every element on the left hand side is minimum than 50 and every element on the right hand side is maximum than 50. I told you, so you know this much about BST. Now when we come to 25, that is the left subtree, every element on the left hand side of 25 is less than 25 and every element on the right hand side of 25 is greater than 25, correct? When you come to the left side of it, because we want to find the minimum, now I will always go to the left side. So where is the left side? That is 15. So the left side of 15 is 10 and the maximum element and the greater element than 15 is on the right. Okay, so we want the lesser element, so we go to the left side again. So here also we will check for its left, but its left is null, so this becomes my minimal element. So how will you find the minimum element is just check the node. Okay, check the node left, node dot left, check the node dot left. When you check the node dot left, if it exists, if it is not null, then go here, then go to your node dot left, correct? So when we were on 50, we go to a node dot left, that is 25. Now 25 also check for its left. Why only for its left? Because minimum element is always on the left side. So check for this, we come to 15. Now check for this, we come to 10. Now when I check for here, we find that the node dot left is null, that is it is the last element, 10 is the last node, so therefore this has to be the minimum node. And similarly, now explain me how maximum node will be executed, how maximum node will be found. Now you know the minimum node is the leftmost element, so the maximum node will be, think about it, it will be the rightmost element, correct? It will be the rightmost element. So 90 is my maximum node. How you will find it is from your root node, go to the right side, always go to the right side. So when I go to the right side, check if the right side node is null or not. It is not null, so go here. Now for this one also check for the right side. If it is null or not, go to the 85 because it is not null. Now again check for the right side. Is it null? No, it is not null. Now again check for the right side. It is null? Yes, it is null. So 90 is my last element on the right side. Therefore this becomes my maximum element. So this is how you will find the minimum element and maximum element. And the recursion is also very simple. All you have to do is check for this condition. If you're for minimum element, check for the left. If left is null, then this becomes my minimal. If it is not null, check for this. If left is null, then this becomes my minimal. If it is not null, check for this. Correct? It is very simple. So now I will write the code for the finding the minimum node and the maximum node, and both the codes are just of 4 lines. Both the codes are just for 4 lines and one line is written else only. So this is so simple, na? This one. So what I will do is I will simply create int min node. Why int? Because I want to pass the minimum element data. I want to return the minimum nodes data, and I will pass my, in the beginning I will pass the root node, then recursion will handle the rest. Simply. Okay, so if node dot left, what I will check, if node dot left is not equal to null, if it is equal to null, let's suppose if it is equal to null, so what we will do, if it is equal to null, then what we have to do, we have to simply pass the return, that is we have to simply return the node dot data. What I am doing here is simply this. So if I am here, that is 25, if my tree is like this 50, okay, and everything is on the right hand side, there is nothing on the left hand side of 50, correct? So if I am doing like this and I am here and I am checking, is node dot left exist? No, it is null. Since it is null, I will pass node dot data. Node dot left is null, therefore I will pass node dot data. So this is what I am doing here, returning the node of data if it is null. Else, if it is not null, what you have to do, you have to return, call the same function, that is min node again, and pass node dot left. Okay, now what did this one happens? Now here, suppose I have 25, so for this one it will check node dot left, it is not null, so again it will call the main function, and again calling the main function, this one will now check for its left. Because of the main function, this one will now check for its left, and when it checks for its left, it sees that it is null, so it will return me the node of data, which is currently 25 because node was 25. So now it will return me a 25 if I do not have anything on the left. For this tree, it will simply return me a 10. For this tree, it will simply return me a 10. I will show you. Let me write the max code also. So max node of node. Okay, so what will happen in the max is same thing that I have done for the minimum, I have to do for the maximum, and the only difference between these two is of left and right. Okay, there I was checking for the left, here I will be checking for the right. So not dot right, if it is equal to null. Now tell me what you will do. What will be the next step? What should I write in the if statement? Come on, you know what should I write? Just write it down on your own code or on the paper, whichever you prefer. So not dot data. Correct. Now what should I do? The last step, return. What should I write? You know what should I write? Just write it down. Max node dot left or right. Should I write left or right? Because we are checking for maximum, we will write right. Okay, maximum always right. Fine. So this is done. This is my min and this is my max. It was that simple, min and max. Okay, we are finding the minimum node and we are finding the maximum node. Now how I will print it? I will simply call, I will just do a single next line and I will simply call s out, because it will return me an integer. So it will print an integer, tree dot min node, and here I will just simply write tree dot root. So we have done this so many times, tree dot root. So tell me what will be the answer for the tree that we have just have, because in this tree I have deleted 90. So tell me the maximum element now. No, sorry, in this tree I have deleted 85. So will it change anything? The maximum element and minimum element. So the minimum element is not changed, so I don't think it should change anything. So the minimum element should be 10 only. Yes, it is 10. And let's see the maximum element. So s out tree dot max element. So I haven't deleted 90 from my tree, so it should not change. So tree dot root and simply run it. When you run it, the maximum element should be 90. Now what will happen if I delete 90? Come on, think. I am deleting it now. You have to tell the answer. You have to know the answer. Tree dot delete. Now if I delete 90, think what will happen. Now if I print tree dot max, what should be the answer? What is the max node now if I delete 90? Let's see. Most of you might know the answer and you are thinking, yes, after 90, what is the maximum element? I know. Yeah. So just tell me what will be the answer. Just match your answers now. Yes, it is 84. Because why? After 90, the maximum element we have is 84. This will become my rightmost node after I delete 90. Okay. So this was my code for minimum element and the maximum element, that is min node and the max node. After this, what will be seeing now is how to search for any node. For example, if I want to search for 25, whether 25 exists in this my tree or not, BST tree or not, I will write a code for that. That is for searching. Okay, not the minimum element, not the maximum element, but any key I will pass, and I want to know whether it exists or not. For that, what I am to do is I will write. So now we will see the searching. Okay, let's see the searching. So search node in BST. So for example, I want to search 46. For example, I want to search 46. So let's search 46. So what will we do? What are the steps? Now you know the steps. Okay, you just have to think about it. You know how to go to left, you know how to go to right, you know what conditions we are using to go to left and right. Okay, so you can easily search 46 in this code. Okay, you can easily write this code. Okay, so what is this here is 50. So first we have to check whether the node is null or not. No, it is not null. It is equal to 40 or not? No. So since both the conditions are failing, we have to check whether we have to go to right, or we have to go to left, or we have to go to right. Okay, first we are checking two conditions, whether it is null or not, equal to null or not, or is it equal to the key that we are searching for or not. Okay, whether it is null or not, or we are searching for a key. Both are failing. Therefore what we will do, we will either go to left side or we will go to the right side. Okay, now how we will do that? That is a if condition. In if condition, we will check if key is less than the node, or we will go to left. If key is greater than the node, we will go to right. Okay, now 46 is less than the node, therefore we will go to left. Correct. Now is it null? No. Is it equal to the 46? No. So again check left or right. Right. 30, is it equal to null? No. Is it equal to 46? No. So left or right? Greater than 30, right? 46, is it equal to null? No. Is it equal to 46? Yes. Yes, it is equal to 46. So return this. Simply return this. Simply say, or simply return true and print, yes, 46 is found. Just do this much. You can do this. It is very, very easy. I think you can easily do this code. Okay. Now you know how to search 46. Not just think how you will search 84. just think for some minutes, give some minutes and think how you will search 84. You will search 50. It is null? No. It is equal to 80? No. Is 80 greater? Yes. Since it is greater, where we will go? Just think about it. Where we will go? We will go to the right side. Correct. So when we go to the right side, it is 75. So 75 null? No. Is 75 equal to 84? No, it is not. So go to left or go to right? Just think. Go to right, because 84 is greater than 75. Then we go to 85. Check for 84. Is 85 null? No. Is 85 equal to 84? No. Is 84 less? Yes. Go to left or right? Since it is less, we go to left. We come to left and we finally found 84 and we will simply return it. So this is this simple. The searching method is this simple to implement. Fine. So what I will do, we need two things. That is a node and a key. So as I've done before, I will just simply create a search method. This method will just contain the key. Okay. And this method will be called from the main method. And I have a node that will store the node that is returned by my real search recursion method. Okay, search key recursion. Okay, and here I will pass the root and a key. Root and a key that is passed to me my main function. I will add some more code in this one. First, let's implement. So node search key result, search key recursion, and here we have a search key recursion, and here we have a node and key. Correct. So this is done. So the next step is, what you have to do, you have to check whether the node is null or not, or we have to check in this one only. Let's check whether it is equal to the key or not. Node.data equal to key or not. Okay, if anything is true, just return the node. If it is null, then it will return a null. If it is a key, then it will return a key. Okay, so it is done. Now if it is not true, this is false. So what we will do, if node.data, or you can say the key, if the key is less than node of data, then we have to go to left or the right. Just think about it, left or right. You have to go to left. So return the search key again, and here this time go to left. So node.left and pass the key. Fine. Then what we have to, now you know how this recursion function works. So return, every recursion function here works the same. Return search key node.right. Now it is going to the right. So if the key is less, we will go here. If the key is greater, then we will not execute the if statement and we will go to the else one. So key dot, and here is the key. Correct. So this is done. This is simple. Or for clarity, I will just write else here. Okay, this is just for clarity. Done. Correct. Over. This is just the 3-line code in search. And now this function will return a node, whether it will return a null or it will return a node. So if it returns a node, it means if it is not equal to null, then what you have to print? You have to simply print that data value is key. Data value key is present. Let me print, or you can say found, since we are searching. Data value key found. Correct. Else what you have to do, system.out.println data value key not found. Data value of key not found. Data value of key not found. Just write it down. 1 second. Not found. Done. So this was a code. This was so simple. Now you know how this recursion function works. You just have to draw the tree for this, and you will know it. Okay. So now let me just, from the main method, let me call this search function. So how you will call the search function? It is very simple. What you have to do, tree.search, and not write anything. What you have to search? Let's see 46. So is 46 present or not? If 46 present, it will simply write down data value 46 is found. Okay. If it is not present, it will say data value 46 is not found. So it is found. We have deleted 90, correct? So let's search for 90. What it says. At the beginning we had a 90, but we have deleted 90 in the middle, in between somewhere. So we have deleted 90. Let's see what it says. So as you can see now, it is running, and yes, data value 90 not found, because we deleted it, therefore we cannot find it. So this was BST. So these were some methods, that is insertion in BST, deletion in BST, finding the minimum node, finding the maximum node. Now you can use this minimum node function to find this also, minimum value. This is iterative, this is recursive. Okay, now we know how to use the search method and what is the search using a recursion. Okay, so you can use in-order traversal also. I have just used a pre-order traversal to just show you the different answers. Okay, you can use in-order and post-order also. Just practice this. Just write your own code. Okay, understand recursion, because in tree recursion is very important. Fine, and this was it. This was very simple. As you can see, not codes are not bigger. Okay, they are intuitive. You need to know how to write these codes. Fine, they are really easy. You just need to understand the concepts behind them. Okay, I think I've given you enough knowledge that you can write your own codes after this. Okay, just practice and you will be able to do it, and you can experiment with this any number of times, any number of ways. Fine, thank you.